me just finish this problem, then I'll give you all a break and you can go make the bathroom or do whatever. Okay? So, a solution containing 3.5 grams of this, okay, and 5 grams of silver nitrate. Okay, that's my given. How many grams of everything else? So in other words, what all are we going to get? So we're going to have X, Y, Z, and W. I did kind of plan ahead there on my letters. Okay? So I need to figure out everything. So what type of problem is this? How do I know? Is this a limiting reactant problem? How do I know that?
You have to find the limiting reactant so you know like how much.
But how do I know I have to do that? What's the telltale sign? What do I read in the problem to know that it's a limiting reactant problem?
Because it asks how many grams of the reactants are left.
It's simpler than that. That's a good reading because it's asking how many grams of reactants. One of them must be left over.
Because you're only given the grams of like the reactants and none of the products. You're given the grams of both.
You have grams of both, okay? Because most of the time they say 3.5 grams react with excess silver nitrate, okay? Or with enough silver nitrate to react completely with it. Or in other words, they only give you the mass of one. When you have the mass of both reactants, that's your telltale sign that it's a limiting reactant problem. Okay? So now we have to find the limiting reactant. Go 3.50 grams sodium carbonate times 1 mole. And what did we get the molar mass to be? 106? 105.99. Yeah, I thought it was 106. Okay? So that turns out to equal
0.0330.
0.0300.
0.0330. There we go.
Moles of sodium carbonate. Okay? And then we do the same thing. 5.00 grams of silver nitrate times 1 mole, 169.9. And that turns out to equal
0.0294.
So it looks like this is the limiting reactant. You got less of it. Well, and what does the balanced equation tell me?
You have to divide that by
I need to have twice as much of this. I'd have to divide this by 2. I don't even have to work it out to know that that's going to come out to be way smaller than that since they're already smaller. So that makes this the limiting reactant. So now I know at the end of the reaction how much sodium carbonate is going to be left. What's the answer to Z? Pardon me, silver nitrate is the limiting. The smaller number is the limiting reactant. Just like I said, this is your limiting reactant right here. So when all is said and done, I was wondering why you guys give me that look, but the bread's beginning to bulge, y'all. I'm getting a little old. You just gotta bear with me. Silver nitrate. So what's the answer to W? 0. Okay? So now it's just 3 separate problems. We got to go figure out what X is, we got to figure out what Y is, and then we can figure out there's several different ways, but we'll just kind of go the traditional way of finding out what Z is. Okay? So, let's just say, okay, now I want to go, I'm always going to use my limiting reactant. I can start with this number of moles, 0.0294 moles of silver nitrate times what? If I'm going for X. Okay? Mole ratio, 2 moles NaNO3 for every 2 moles AgNO3. Go to grams. You use the molar mass, 16 times 3 is 48, plus 14 is 62, plus 23 is 85. And it's probably 85.0 because this is 23.9 and that's gonna be 14.01. So, 85.00 grams. And that turns out to equal,
I got 2.5 here. I
Two- also got that, 2.50. Of NaNO3. I did have to take off a point on a couple of people's tests because they didn't put units and they didn't put a label on their answer. Okay, so I'm gonna count units and labels. You gotta make sure. Okay, now just real quickly, if I wanna do Y, what's the only thing that's gonna change? I'm gonna have the mole ratio here, this is gonna be 1 mole of Ag2CO3. And then I'm gonna change the molar mass here to
275.75.
275. Okay. And then that's gonna make it turn out to equal
4.06. If you do that.
double check, so it'd be 0.0294 divided by 2 times 275.75. 4.06 grams of silver carbonate. Okay? So now how do we go through and find sodium carbonate? Gonna do the same thing, make this my unknown, but that's gonna tell me how much is used. We're gonna subtract that from the 3.5 to find out how much is excess. So we just kinda go through and do the same thing. Let's do it in green for Z. Because I don't wanna change the video here. So now for 3.50, all I'm gonna do is I'm gonna start with the same thing. My mole ratio is gonna be 1/2, but this time it's going to be of Na2CO3. And then my molar mass of Na2CO3 we already know to be 105.99. So that turns out to equal, I go 0.0294 divided by 2 times 105.99.
1.56.
1.56 grams. Is that what we got? Sodium carbonate, but that's the amount used. Right? So the excess, 3.50 minus 1.56 is gonna equal 1.44? No, 1.94? Sodium carbonate. So that's how much would be excess left over, 1.94. Okay? So you're just gonna do all three. You just find your limiting reactant, convert both the moles, divide by the smallest, divide by the coefficient. The smallest is your limiting reactant. Always use the limiting reactant, and then you just use your mole ratio and molar mass to find the rest of them. We all good with that? All right. We'll take a break and then come back. Is this the stop right here?